All right, welcome to another coding session. This is Bangalang 11. We're getting quite far in the series now. And I'm pretty happy where we are with our language. So just to recap, we're creating Bangalang, which is a low-level explicit procedural language with the lofty goal of allowing easy execution on the CPU and GPU with the single language. But right now we're just doing language basics, just so we can do simple things. If we have a look at the language, we have declaration with the colon equals. We can assign to variables. We can have inline scopes. We can have expressions, which is what I call almost bedmass. Everything except for exponents, which should be solved with procedures, which is our next thing that we're going to do. We have if statements, else if, else. We could even nest the statements, and we have loops. So we just use the keyword for, which is an idea that I stole from Odin. So even though this is more like a while loop, really, we do use the keyword for. And because we don't have any types yet, the only type of variable we have is a 64-bit integer. So the condition is just checking whether that integer is 0 or not. And here's a more typical for loop. And so here is a procedure call. And procedures is what I want to tackle next. And I feel like procedures is quite a big thing. So first, we're going to start by basically just making it so that under the hood, this is actually doing a procedure call. Because right now, it's just inline hard-coded assembly. So we'll switch this to a procedure call, and then we'll see what we can manage to do after that. But I feel like it's a good idea, especially with this challenge that I set myself where I need to, get something useful done in 1 hour. It's nice to break it into small steps. So the first step is to get this working as a procedure call. Now, if we go up here, we can do a little bit of an explanation about how procedure calls work. Maybe I'll just copy this so we get like the same text size, how they work in assembly. So in assembly, we have labels. Oops. So if I have a label that's like my proc, and then in here I have like some instructions. Let's make it a bit wider and maybe zoom in. Like this. Then up here we have, instructions, and then the way up until now that we've been jumping to labels is just using some sort of jump. So I just put a non-conditional jump here, and this would take us to here, to my proc. The problem with this is that once we've finished the procedure, we want to go back and continue these instructions. So the idea behind a procedure call, which is where we change this to call, is that it also allows us, then we can have another instruction here, which is return. Where is, there we go. Here is our stack. So maybe I'll just copy this and bring it over here. So if I say that this is our stack, oops. And it's got some variables on it. So what happens when we do call? Well, the first thing is that I don't know if there's a better way to say this, but the instruction pointer gets put on the stack. That's the first thing that happens. Oops. Is we push onto the stack the instruction pointer. Now the second thing that happens is, maybe I'll just put this over like this. The second thing that happens is that we jump to my procedure, to this label. Then we do all these instructions. And when we come across the return instruction, what's going to happen is that it's going to pop that back off. So 3 is that we pop our instruction off of the stack. So maybe I'll put that sort of down the bottom there, kind of get this out of the way a little bit, because then I want to do another arrow up to here, because this is, oh, why can't I, there we go. This is the last thing that happens, is that it, uses that instruction pointer to take us back here, and then we continue. So basically that's how procedure calls work in assembly. I don't know if you can really even call them procedure calls. I mean, they do use the name call here. So I guess it is a procedure call. So that's what we want to mimic, well, that's what we want to create in our code. Actually, before we start, there's just a little bit of maintenance I need to do just quickly. In our generation of the for loop, there was something a bit messy that I did, and I just want to comment it. What happens is that this declaration here at the start of the for loop is not scoped to the for loop. So if I try to do this again with the same variable name, it's going to say failed to generate declaration duplicate identifier at line 64. So that shouldn't be the case. This should be scoped to the for, so we could reuse the name further down. But that's not the case, so I'm just going to say should be scoped to for loop. And then in our parser, we loop through statements, parsing them. And if we come to a keyword as the first token, then it checks whether it's for or if and parses the correct things. But if it was a different keyword, then it would just do nothing, which doesn't advance the stream. So we're just going to keep looping. We're going to be in an infinite loop. So I just want to prevent that from happening. If we can just grab this error handling, failed to parse statement is fine. Okay, so that's the little bit of housekeeping out of the way. So we're not going to change our grammar to start with. The grammar is exactly the same. Just exit bracket, expression bracket. It's just under the hood we want to change stuff. So the parser also, I think, doesn't need to change. What does need to change is when we generate, if I can find it, when we generate our exit. So at the moment it generates an expression, and then this code here is a Linux system call, which is the exit system call. So it executes that code. Now, instead of putting this inline here, we want it to be separate in a procedure. So the simplest way I can think of to do that is if we come up here. So this is this is when we first enter into our program. This is the top level function. And you can see right at the end here. So right at the end, if I run this now, right at the end, we can see there's this default exit. So that's this here. So the idea of that is, well, see, now we're not actually, now our exit, because we just took that code out, is not doing anything. So the idea of the default exit is if we don't explicitly exit the program, then this will do an exit code of 0. And that's required because if we don't do an exit code of 0, then we get a segmentation fault, which is not the nicest way to end a program. So what I'm going to do is I'm going to put our exit procedure, so I just put an exit label here, after this default exit. So our code's never going to accidentally flow down into here because it would have to come past the exit. And once this syscall happens, then the program finishes. So we put this after here, so it's not in our normal program flow. This is our parameter, and we're going to keep this at R8 just to be simple. Sorry, that's the wrong place. So down here, when we're generating our exit, see, we generate this expression, and the way I've done expressions is that an expression will always put its result in R8, register R8. So then we know, that's kind of like our calling convention right now. You could say our calling convention is that we only accept one parameter, and that parameter is an R8. And then, well, it's kind of not needed because, you can never actually return from this exit. So it's a little bit unneeded, because this syscall is going to end the program. So this return is a bit pointless, actually. So I guess we can't test returning with this, but we'll try to do that a bit later. And I'll put this here just for completeness. Just a procedure should start with a label and end with a return. That's kind of the structure of a procedure. And then over here, oh, sorry, wrong place. Over here, in our exit, we're still going to generate the expression, but then we're going to call exit. I'll say call procedure. And that's basically it, I think, for our very simple example. So if I compile that, so now we see we have our default exit. After that, we have our exit procedure. And up here, when we do our manual exit, so that's this line here, you can see we put something into R8 and then we call exit. And exit is using R8. So it's not much different to what we had before. It's basically just jumping down here to do the work instead of doing it in place. But it's a start. So let's just verify that that works. We should get 55, because that's the sum of our loop. Great. Now the next thing I want to do is I think I want to expand this grammar. So instead of just exit, I'm going to say this is a call. And I'm going to say that it starts with an identifier, which is the name of the procedure that we're calling, right? At the moment, exit is the only one that's going to work. And still, we're just going to accept a single parameter. But now we're also going to try return values. So we'll put call up here. So it's up here. So a statement could be just a function call, which is what a procedure call, which is what we have here. Or it could be, I'm going to put it in primary as well. So it could be part of an expression, a primary element to an expression. So maybe I'll put it there. We'll just put an or before it, there. So it could be in here as well. Okay. And the reason I want to do that is because I want to test the return. So I want to be able to do something like +1, sum1, and then we can go sum1 +1 and assign it the result of +1 of sum1. Right, so for this, we're going to need to upgrade our parser because we changed our grammar. So instead of an exit, we need to change it to call, and we need to implement this so that it can be part of primary. We also need to generalize our call, so it could be any identifier. So when we parse, parse scope, parse declaration assignment, parse exit. Because I like to keep this in the same order as my grammar, then I find it a bit easier to find. I mean, maybe I should break this into multiple files at some point because they're getting quite big, but I'm not in a hurry to do these kind of things. So let's say parse call, and we'll use a node type of call instead of exit. Right now we're verifying that it is the word exit. I don't think that's the job of the parser, actually. Because instead of just saying exit, now we're going to verify that it is a declared procedure. We're not going to get into, so I don't think we'll get to defining in our own procedures yet, like defining a procedure within Bangalang. We're probably just going to stick to hard-coded procedures, you know, like the exit procedure is just hard-coded at the end of the file. We'll probably just stick to that. But the idea is that there is, you know, there are declared procedures and those are the ones you can use. But I think that's the job of generation to understand, not the parser. Maybe we'll change that at some point, but that's kind of how it is. That's how I've structured things so far, that the generator is responsible for that sort of stuff. So here's an example of creating an identifier node. So we're just going to do that. And we might call that the name, because it's the name of the procedure we're calling. Yeah, it's good enough. So we need to change that exit. We'll put it down here to call. Okay, so now we have an extra child. One child, two child to a call. And here, if we go in, if we have a statement that's identify opening bracket, then we are parsing a call. Great. What I also said was that in an expression, no, in a primary, right, as part of the primary, we need to, a primary could be a call. So in here we have these special cases, and I'm going to add another special case in here. If the first token is an identifier and the second token, so we do offset 1, is an opening bracket, bracket, that means it's a call. So we do parse call. But we don't need to wrap it in a gate. there's no tokens we need to consume at this point. I think we can just say that our node is a call node. Just a sign like that. I think we can just do that. So now we have this call here and this call here, and we've generalized this so that it could be any identifier. I think that's pretty good. So now we can go to generation. So this needs to be call now, and generate call. Okay. And when we have generate, there should be a generate exit in here. Generate exit. Again, I'll move this down to the bottom. And we'll change it to generate call. Because this can be called inside of an expression, I don't really want, like this is kind of a statement level thing that I was doing where I print at the start. Like at the start of a statement, I will print. So I think I'm going to put this here instead, so that in the case that the call is the statement, we should print. But if it's just part of an expression, I don't really want that comment there. Okay, so now we have two children in here. Not only the param node, but the name node as well. And the name is what we substitute in here, right? Yeah, so that's what we're calling. But this is where I wanted to do some checking also. Before we just call some random name that we were given, I think we should check to see whether it is a declared procedure, you know, like I was talking about before. Eventually, once we actually start defining our own procedures within the Bangalang source code, we'll keep track of all of those. But right now, I'm just going to put just a static list. So we'll call them procedure names. And I'm going to make it a slice of strings. And we have exit and +1, right? Those are our two valid procedures. So now if we go down to our generate call, I just want to say found procedure name. And then for procedure name and procedure names, I want to say if procedure name equals the name node value, then we have found the procedure name. We can break. But if we did not find it, then that's an error, right? That's like, yeah, it's like undeclared identifier. Generate term. That's some old terminology. It should be generate primary, failed to generate primary. And here it's failed to generate call because the identifier was undeclared. So we have some checking in here. And then we call the procedure. So failed to generate primary undeclared identifier +1. Okay. I thought that it would work. I know we have missed out something. So maybe we'll just add, see here, I think we need to actually implement the procedure, we're just going to hard code it here because we don't have a way to actually do it in the code. And if R8 is the parameter, and I think I'll just make R8 the return as well. Yeah, we'll just make R8 the return as well. So in this case, +1 is just like add R8 1, right? That's the assembly for adding 1. Well, actually, let me try. I haven't tried this before. I think that's increment. So I think we can increment R8. Let's try that. Yeah, that's +1. So I think we have all the code we need, but failed to generate primary. It seems that the computer says no. So failed to generate primary, undeclared identifier. That sounds like it's gone in here, doesn't it? That's what it sounds like. Identifier. What is the identifier? +1. Yeah, that's right. I mean, it's not right. It shouldn't be doing... This should be the name of the call. Well, I guess it should be an identifier node, actually, but it should be within the call. Right? If I go to my parse call, yeah, we have a call node. And the first one, the first child out of it should be the +1. It's the identifier. So let's go back up again. Yeah, here's our call. So why is it doing this? When we get the call node, the call is a primary. We just want to call this. But because this has 1, 2 children, then this doesn't work. You know, it generates the primary. No, I mean, it doesn't generate the primary, and instead it goes and tries to do some arithmetic with it. So this condition's not working anymore. And really, I think the idea of this function is to do these binary operator. Yeah, do these binary operations. So I think we can just say that if the node is not one of these, then we want to generate a primary. Maybe that's a better condition. So if node.type does not equal add and does not equal subtract and it does not equal multiply and it does not equal divide, then we generate primary. Let's try that. Wow. Okay, I haven't come across that before. Can I debug it for a while and then, oh, okay. So it's going to tell us where it happened. Look at that. I guess it's basically a Stack Overflow, right? It's just infinitely recursing in. Because it's generating primary, which is generating expression. So we forgot to, yeah. So in the parser, we put our call here and here, but in the generation, we forgot to implement that. We didn't put our we didn't put our call inside the primary. I think I'm going to change this to a switch because I feel like I've been a bit inconsistent with the way that I code things. Some things are switches, some things really are not. Or, you know, if else, but really it's the same kind of structure that I'm just doing in two different ways. So I'm going to put this in here. In the case of an identifier, then if we have an integer literal, we want to do just this line. And because in Odin, because remember we're using, this is the language I'm writing in right now is Odin. With switches, it doesn't fall through by default. So if it goes into this case, it's not going to fall through into this case. If I wanted it to do that, I would have to do this. I'd have to explicitly say that I want to fall through. So I don't have to worry about that, which is really nice. Then we can say case negate. There's those two lines. And this is the default case. Maybe it shouldn't be the default case because that's what made us infinitely recurse. Maybe we should actually check. So actually what we're looking, this should be an opening bracket. Because this is that right? If the primary is an expression, parse expression. Does parse expression take care of the brackets? Where do the brackets get taken care of? Oh, wait a minute, this is just parsing. Yeah, but somewhere we need to parse the brackets, right? There should be like opening bracket, close bracket. Where does that happen? Oh, sorry, this is generation. This is generation. Parsing is where we're concerned with brackets. Yeah, this is where we're concerned with brackets, right? And if we get an expression, we're not sure what node it might be. Yeah, we don't really know what node it's going to be. That's why we put it in the default. Okay, we'll just leave it as a default. But we're going to add another case in here. And because I like to be alphabetical, I'll put it at the top. A call, which I believe is just generate call. I don't think we need to do anything. Oh, do we need the register num? Do we need the register num? Well, we want to return, right? From, like if I go up here, we're incrementing the parameter, but then we need to also return it. You know, like in this case, we need to assign the result of this expression to this variable. And in the context of an expression, which is where we are, I think we need to take in the register num, because that register num is where the next level up of the expression is expecting, like, it's a bit hard to explain, but this generate call, it expects that whatever we do in here, it expects that the result goes here. So maybe there's an example of it. Yeah, see, like this. So an integer literal is putting the integer into the register num. An identifier is moving from the stack into the register num. So whatever we do here, the result needs to end up in that register num. So we do need to pass that down to generate call. I'm going to give it a default of 8 because we do also call it up here, right? And in that case, we'll use 8, which is because the register numbers start from 8. R8 is the lowest numbered register. Okay. Generate call. Yeah, so now we need to implement this, right? I mean, we have basically implemented it. The one thing we haven't implemented is this register number now. So I think, well, that needs to be printf line. And then I think we just do a move, right? From to whatever register it is from R8, because we know we're coming from R8 because our calling convention is that the parameter and the return value of a procedure are both R8. So, and then we put it in the register num. Let's see what happens. Let's see what happens. Exit code 0. It's a nice start. So we declare and we call, so this is after the for loop. Yeah, we've got a declaration, whoops, and a call. So this is the line that, well, this is the line we had before. This is the procedure call we had before, and it still looks right. You know, we put a variable in R8, we call, this is us grabbing the return value, which is pointless with an exit. And it's also basically a no op. So we could probably optimize that out, but I don't see the harm in it, so we'll just leave it for now. And this is our new one. So we put a variable in R8, like normal, then we call +1, then we move R8 to R8, and we push R8. So it's a lot of movement of R8. And our +1 is down here, which just increments R8 and returns. Very simple stuff. I think it should all work. Let's see what happens. We already did that, so let's just run it. We should get 56. 56. Nice. Nice. Now let's do something a little more challenging then. What if we put it in here and then we do like, you know, +4 times 2. So the precedence is that I would expect this to happen first and then this, and then the result of this and this get added together. So we've established that this is 56 plus 1 again, that's 57, plus 8 is 65, right? Is it gonna compile? It compiles. Does it look like it makes sense? Here it is. It's a bit complex. So we take the variable we just created, we call +1 with it, we assign the return value into R10 this time. So that's why, you know, we needed to have this. We needed the register number, because in this context, the expression is expecting it to be an R10. We also assign another couple of values. Oh, the 4 and the 2. Interesting. So I think I've seen this before where it does this in an order that I was not quite expecting. So it's setting up this value, which is this one. And then it's setting up the 2 values for this, multiply. Then it performs the multiply with these 2 and puts the result in R11. So now we have, oh yeah, I guess that's right actually. So this is handling the left-hand side. This is handling the right-hand side of the plus, I mean. And then this is doing the plus. Yeah. And putting the result in R8 and then calling exit with R8 and then doing our pointless return assignment. So that should work, right? I mean, it looks good. $65, that's what we said. So this ret is definitely working, right? Because +1 ret, I mean, if that was not working, then we would be all over the place. If we did a +1 and the ret didn't work, the program would just end. And it would segmentation fault because it didn't end nicely. We didn't tell it we were ending, and we just, you know, it's like when you leave a party without saying goodbye. Okay. Whew. I hope that wasn't too fast going through that. If I'm honest, this is the second time I'm recording this video because the first time the recording glitched out. It just had like a still frame across the whole video. So I'm doing this a second time. So that, I hope I didn't too fast. I hope it all made sense. And maybe a bit of speed is better actually, who knows? I think some videos have been faster than others. But I think we've made some good progress and we still have a bit of time. So what else can we do in here? Maybe we can add multiple parameters. I feel like that could be a nice thing. Then maybe we could actually create a POW function. You know, most languages have a POW, P-O-W, which is like raising a number to a certain power. So it could be squaring a number or cubing. For some reason it's escaped me, but I think it's called cubing when you go to the power 3. Cubed, squared, cubed. I think that sounds right. So you can have one or more expressions in here. Actually, I guess technically we could have an empty one as well. There could be no expressions. So how do we say that? Like one or more comma separated. That's a bit of an annoying thing to try and express in this notation. So I guess to start with, it's going to be a group, right? It's going to be a group of things like this. And then maybe within that, I'm really winging it here, but somehow this feels right that we would have another group. That has a comma token and then another expression. And there could be multiple of these. What have I done wrong? I need to put it on this side. So this group here, there could be multiple comma expressions after the initial one. Yeah, so an expression followed optionally by more expressions, and they're all comma separated. And then this whole expression group business is it's this one, isn't it? I keep putting it after the slash. Is optional. The question mark means that whole thing is optional, because there could be no parameters, right? There could be no parameters. Yeah, so we don't need to do anything with we haven't even touched the tokenizer, and I think we still don't need to touch the tokenizer. And I've gone past that previous video I was talking about now, so things might slow down a bit, but let's see how we go. So now I think we need to, in our generation, well, in our parsing, let's start from the beginning. When we parse a call, now we need to handle the fact that there might be no expressions, there might be multiple expressions. So let's say if peak token type is an expression. Oh, but we don't have an expression. So let's just say if it's not a closing bracket, maybe it would be good to have an expression node, just because then it helps us to verify at certain points that we're dealing with an expression. Right now, an expression could be just a primary, or it could be a binary operator with two primaries below it. It could be a call. It could be all sorts of things. So maybe at some point we will make an expression node in our AST. Right now, this is fine. So if it's not a closing bracket, that means we have an expression. All right. Well, let's say 4. While it's not a closing bracket, we want to parse an expression. And after we parse the expression, if still it's not a closing bracket, that means it must be a comma, right? Yeah, if we don't have a closing bracket yet, we have an expression, which is to say a parameter. Let's see, parameter node. And then after that, we can either have a closing bracket or a comma. So if we do have a closing bracket, then this is we're going to skip this and break out of the loop and then just consume the closing bracket. But if it's not a closing bracket, then we should have a comma and then loop around, and this will also be evaluated true, and we'll go into here, and then we pass the next expression, the next parameter. So now we can have 0 or more parameter nodes in our AST. Okay, I think that's that. I think if we were to compile and run that, it should still work. Our generation is assuming there's only one parameter node, but our code only has one parameter node right now. So it should work. Yeah, 65. But this is not going to work. So let's keep track of the child index. Like that. I think we need the name node before we do this verification. And so we're verifying the name I feel like we also need to verify the number of parameters now. Because if we get that wrong, I mean, I don't know what's going to happen. Something that's not so great. So our procedure names, instead of just having names, we actually need to keep track of names and parameter counts. So let's just make a new procedure struct with a name and a param count, like that. A param count? No, param count. And eventually we'll put that into this context. But right now, I think we can just say we want a list of procedures. The first one is exit with 1. And the next one is +1 with 1. Like that. Those are our two procedures. So we go procedures, procedure dot name. Is that right? Yeah. And procedure dot param count equals the number of children minus 1. Because when we're parsing, we create the call node. The first child is the name of the procedure, and then after that we create a child for every parameter. So here's the name of the procedure, this is the first child. So the number of children minus 1 is the number of parameters. So what's wrong here? Because this... Oh, we can't do that, huh? Because this is the type. I could do like _t or something. Sometimes I do that. But let's just say the procedure. Is that going to be happy? Come on. Oh. Undeclared name procedures? Oh, I still call it procedure names. That's why. So maybe I can do procedure? I think it's happy. Okay, so now we're verifying that there's the right amount of parameters as well. And we'll just say found procedure. This error message is not right, but that's fine for now. Now we need to do a for loop here. That's going to say, you know, while child index is less than the length of children. So as long as we have more children to take care of, we generate an expression let's do something like this first. So this is the param node. So we're getting the next child, and it's the param node, and we generate an expression from it. So now our calling convention will need to change a little bit, right? Because we can't just use... I feel like it's going to be too dangerous just to use like R8, R9, R10, R11, because I feel like it's going to conflict with our expression stuff, potentially. So I think what I want to do is I want to push them onto the stack. So then within the procedure, you just have to know that they are on the stack. Okay. And the tricky thing about that we'll have to figure out is that, remember, when we do the call, we're also pushing something onto the stack. And I don't know how big this is. It's a pointer, so I guess it's 64-bit because, you know, computers these days have 64-bit address spaces, so pointers 64-bit. I hope. Let's see. Actually, this is more relevant. So once we generate an expression, well, we want to push it, right? Push it onto the stack. Yeah, we push it onto the stack. So that should be the same as declaration, like this. Yeah, push to stack. And then we do some management here, which we will need to eventually do, I guess. So we'll probably do that. We'll probably amend the context, tell the context about these variables so that we can so that inside the procedure we can just use the context to access them. I think that would be nice. But right now we're going to just, for each parameter, we'll generate the expression, which will put the result in R8, and then we'll push that onto the stack. So we have all of our parameters on the stack, followed by the instruction pointer on the stack that call puts there. So the implication of that, I think all of this is good. I think we're all good. But the implication is that now in here, these R8 is not correct. We're still going to return with R8. I think let's continue to return with R8 for now, but we're not passing into R8. So what we're actually passing in is, we'll need RSP plus 8, I think, because RSP plus 0, so that's the top of the stack, is this guy. So we'll go 8 bytes down to get this guy, which should be parameter, right? Parameter should be there. So we'll go plus 8. We only have one parameter, so that should be that guy. And we don't need to worry about the return value. And here, this is arg0. I'm just going to say assign arg0. So we're going to put the first assign, the parameter, we're going to put it in R8, increment R8, and then our return value is R8, right? So I don't know how confident I am that this is going to work. I don't know how confident I am. I was going to say, well, at least the assembly is going to look right, but it doesn't. So that's our push. That doesn't look right. Go to generation. That should be when we're generating our call that we do our push. Where are we? Here. Because we don't need to specify where we're pushing from. We know that it's R8. So let's try that. Yeah. I think that looks at least formatted correctly. So yeah, so now when we do this declare, this statement here, we're starting by putting our value in R8 and then pushing R8 onto the stack, calling +1, assigning our return value to R8. So we're assigning R8 to R8. That's not right. That's not right. Because the return value is not in R8. It's in, at this point, it will be RSP plus 0 because we've come back from the call. So this has been popped off the stack already. So we're at RSP plus 0. Ooh, this is getting complicated, isn't it? So this R8 is wrong. Or is it? No. We did say that the return value is R8. Yeah, we said the return value is R8. So this is correct. And we're just putting it in R8 because that's, and pushing to the stack because that's how we do declaration. Okay, this is how we do expressions, and well, I guess yeah, that's fine. That's fine. But one thing I noticed that is missing in here is that we've pushed onto the stack our parameter for here, but then after the call we should really we need to I don't know if we have any way that we do it now, do we? When we leave a scope, scope end, there must be a scope here where we do it. Scope end. We have so many scopes now. I think it's, look at how much assembly we have. Holy shit. Okay, up here, close scope. So we add to the stack pointer. So that's effectively, if the stack pointer was here, then we add to the stack pointer to go down here, which effectively takes this off the stack. It's like popping it off the stack. Maybe there's a pop, but I'm just going to do an add because we might have, so here we need to count how many parameters we had, times that by 8 and subtract it. Or not subtract it, add it, right? Yeah, add it. So let's copy that. That's kind of, oops, I keep jumping to there. Sorry for jumping around a lot. I'm going to try and reduce that. It's one of the things I'm working on. So we'll say clear params from stack. So we're going to add to the stack pointer the param count. Well, do we know the param count? We didn't save the procedure. We could have saved the procedure, then we have the param count. But it's not hard. It's not hard to get. It's this. Param count times 8. 8 bytes per parameter. So now if we go back to the bottom, here, see we call, now we clear the parameters from the stack. We assign our return value. So that's kind of cleanup. Yeah, so we put in the parameters in, we do the call, then we take the parameters back out again because we don't want to waste stack space. And then we do our assignment. Okay, let's see if this actually works. $65. Wow, this is amazing. We're a little over an hour, but now that we have done multiple parameters, I just want to, I feel like I'm playing with fire here, but I just want to try it out. Let's try and implement the POW that I was talking about before. No, I think because we don't have much time, we'll just go for a simple function. So we'll just go my add, or just add is fine. And because I'm a stickler, it needs to be in alphabetical order. So let's go add. So we should get 2 parameters. So we'll move one of them into, I guess this would be, arg0 would actually be plus 16. And then we do an add of R8 and RSP8. That's the other parameter. And then we return. Oh, I think that's it. So if I go add 25, so that should be 70 now. No. Because now we're doing 4 sevens, which is 28, plus, what was this? 56, 57. 57 plus 28 is 70, 85. Oh, I feel like I'm really testing my maths here. 85. Whoa, look at that. We add. And if we try to just add 2, it's not a great error, especially because it just has an empty thing. It should say not enough parameters, but whatever, close enough. But why is it an empty string? Failed to generate call. Failed to generate call. That's here. Undeclared identifier. Node. We should be talking about the name node here. Yeah. Undeclared identifier, which is not right, but good enough for now. And what if we put like sum1 here? Because it's saying undeclared identifier. This is a declared identifier. And it still says undeclared identifier, which is also not right. What we actually need to check here is the type of sum1. Sum1 is a 64-bit integer. So we kind of have 2 types now, 64-bit integers and procedures. But we don't have any concept of types in our language yet. We want to be statically typed. I don't know if I mentioned that yet. Statically typed. But I'm super happy with where we've got. We've got multiple parameters, returns. So we've got a calling convention. Maybe I'll just put that up there just to tempt a little more fate. 37. So that's 7 plus 1 is 8, plus 1 is 9. 9 plus 28 is 37. Yeah. I just wanted to put it like before the last statement because, we're playing with stack stuff and I kind of wanted to make sure that the stack was still working properly. Like I guess actually using an older variable would be a better way to check that the stack was not corrupted. Oh no, yeah, that's 50. Of course it's going to be a different answer. That's 55. So that's 56 plus 28. 56, 28 is 70, 84? 84, yeah, okay. Perfect, okay. I'm gonna stop here before I do anything that ruins everything. But I'm really happy with where we're at. And I think definitely in the next episode, we can move on to actually declaring our own procedures in here. I think we should have a go at the POW procedure. Write our own POW in our language. But I'm really happy with where things are right now. I think the last few episodes, things have really been cranking up. It's nice. But now I'm going to say thanks for stopping by. Don't forget to like the video if you want me to continue the series. I mean, I'm going to continue it anyway. I'm really enjoying it, but the like doesn't hurt. And yeah, ciao for now.